Hello everyone. Today we are going to learn the basics of digital electronics. In basic electronics, all the operations use 0 and 1, which are binary numbers. And for logical operations on these binary numbers, we need to use some circuits. Those circuits are called logic gates. In this video, we are going to learn what logic gates are, how we can use them. And we are going to learn the basic logic gates, which are AND, OR, and NOT. Logic gates are digital circuits. They take one or more input to produce a single binary output. Now the output depends upon the type of gate we are using and the logical operation that gate performs. Because of these logical gates, we were able to make ICs and microcontrollers, also microprocessors. Let us first understand AND gate. Here we have two input AND gate, and an AND gate only outputs a high signal when both of the inputs are high. For example, if on input A I give 0 and input B I give 0, we get 0. Similarly, if I give 1 on input A and 0 on input B, again we'll be getting a 0. If I do the opposite, give 0 to A and 1 to B, again we'll be getting a 0. It only outputs high if both the inputs are high. That means if I give 1 on A and 1 on B, only then I'll be getting 1 on the output. This may look familiar to you guys, since any two numbers can be 0 if they are getting multiplied by 0. So here 0 and 0 gives us 0, 1 and 0 also gives us 0, 0 and 1 also gives us 0, and only 1 and 1 gives us 1. Hence, it is a logical multiplication of binary numbers. Next we have OR gate. Similarly, just like the previous AND gate, we have two input OR gate here, and in OR gate it will give out a high signal even if one of the input is high. That means if either one of the input A or B is high, that means if you are giving it 1 on either of the input, we will get a 1 at the output. Let's see. Here if I am putting 0 and 0, that means 0 on A and 0 on B, we are going to get 0. But as soon as one of the input gets high, that means 1, and the other one is 0, we are going to get 1. Similarly, 0 and 1 here, 1 on B will also output 1. And 1 and 1 will output 1 as well. The table that we are filling is called truth table for this particular gate. And since we are getting high on any of the high signal, this gate performs a logical addition. Now let us understand NOT gate. Unlike all the other gates which has two inputs, this only has one input. So this is called a single input gate, and whatever we give here at A point will get the inverted of that on Q. That means if we give on A, we give 0, we will get 1 on the output, and if we put 1 on the input, we are going to get 0 on the output. This gate is also called the inverter because it flips the value whatever we are feeding it. Now comes the important part. Why logical gates are important? These are important because these are the basic building blocks of any electronic circuit. Or the more complex the circuit, the more logic gates are being used in there. You might have seen a microprocessor or a microcontroller. These are just combination of these logic gates. And without these logic gates, we will not be able to make any computer or smartphones. So to summarize all this, I'll say these are very important, and as they are the building blocks of electronics, we must learn it so that we can move ahead and explore more. Hope to see you in the next video.